Hi, welcome to MooMooMath. Today we are going to talk about geometry topics that we need for pre-calculus. So here is the first one, okay? Distance and midpoint. So here's your distance formula, and here's your midpoint formula. And I wrote those down just to give you easy access, and we're going to find the distance and midpoint of the segment AB. So to find the distance, I'm going to label my coordinates x1 and y1 and x2 and y2. And that's my first pair, my second pair, and then I'm just going to plug and chug. So I'm going to take x sub 2, which is -5, and I'm going to subtract 1, and I'm going to square all that. And then I'm going to add y minus y, so y sub 2 is 0, minus a -3 squared. So that's going to give me -6 quantity squared plus double negative becomes a positive, so that's just 3 squared. And I'm taking the square root of that sum. So that's going to give me 36 plus 9. And that's all under the radical, so 36 and 9 is 45. So I'm taking the square root of 45 as my distance. Now this one will simplify, so let's simplify the square root of 45, and we know that's 9 times 5. So that's going to simplify to 3 square root of 5. And that is the distance or the length of the segment AB. Now let's find the midpoint of AB. Again, I'm using my label coordinates. I add my x coordinates, divide by 2, and I add my y coordinates and divide by 2. So 1 plus -5, all divided by 2. That's going to give me -4. -4 divided by 2 is -2. So that's my x coordinate. And then my y coordinates, I'm going to take -3. I'm going to add 0. And divide that sum by 2, so that's just -3 halves, and that is my y coordinate. So the midpoint is at the point -2, -3 halves, which is also -1.5. So there's my distance and midpoint review. Now let's talk about the Pythagorean theorem. Okay, Pythagorean theorem, I hope you remember, that's just a squared plus b squared equals c squared. And that should be very easy to remember. That's something you learned in middle school. Okay, now let's just plug and chug. A and b are both the legs, and c is your hypotenuse. Well, we don't know c, so I'm just going to label that one c, and I'm going to use 4 for a and 6 for b, but those are interchangeable. So let's just do a quick review of this, and that's going to be 16 plus 36. And that's c squared. Now, I'll add my c squared up here. And then 6 and 6 is 12. Carry the 1, so that's 52 is c squared. And I'm going to take the square root of both sides. And that becomes 13 times 4 is 52. And 4 is a perfect square, so that simplifies to 2 square root of 13. And now when you take the square root of something in an equation, you can actually think of this as a positive and a negative. The only catch is on the Pythagorean theorem, you can't have a negative length, so you are going to take the positive value on that. So that's just 2 square root of 13. Okay, now let's review special right triangles. We've got your 30, 60, 90 and your 45, 45, 90. And I have these double starred because these are very, very important for pre-calculus. You build the unit circle with these triangles, so you need to know these. So you need to know these rules. Okay, for 30, 60, 90, if your smaller angle is 30, opposite it is your smaller side, which we're going to call x. The hypotenuse would then be 2x, so you double the short leg, and then if you take the short leg and multiply by radical 3, you get the long leg. So let's look at a couple examples. We'll start with something easy. if you have a short leg that's 10, then the long leg, we just take 10 and we multiply it by the square root of 3, so that's just 10 square root of 3. And then you take the short leg and double it to 20. So if you're given the short leg, that one's pretty easy. It's just short leg doubled, short leg times the square root of 3. Now, let's look at it a little bit differently. What if we start instead with a hypotenuse? So let's say we're starting off with 6 as the hypotenuse. Well, 6 is equal to 2x, so that means x has to be 3. So my short leg's 3, and if the short leg is 3, then I multiply it by root 3, so my long leg is 3 root 3. And that's how you would work it if you're given the hypotenuse. And then the last one, the last method, is what if you're given the longer leg? And so let's say you're given the long leg is 12, and you have to work back to the short leg, because you're always going to go back to the short leg. Whichever one you're given first, you need to know the short leg. So 12 is equal to the long leg, which is written as x root 3. And if we divide both sides by root 3, we just have to use a little bit of rationalizing. And so that ends up being 12 over the square root of 3. And then multiply it by radical 3 to clean it up so we don't have an irrational number in the denominator. And that gives us 4 square root 3. Because radical 3 times radical 3, remember that's just 3, and 12 divided by 3 is 4. So that gives us 4 root 3. Well, I'm going to take that and multiply it times 2 to get the hypotenuse. So if I take 4 radical 3 and multiply by 2, I'm going to get 8 radical 3. And that is my answer here. And just to review, radicals, let's talk about that. 4 times the square root of 3 times 2. Remember that we have outside times outside, or 4 times 2 is 8. And that's how you'd solve that one. Okay, now let's look at a 45, 45, 90. Okay, 45, 45, 90. Remember, these two acute angles are 45s. That means these two sides are the same, which is both x and x. So let's start with an easy one. Let's start with if we're given the leg. If we're given the leg, this one's 10. And then, of course, this one is the same because it's isosceles, meaning both sides are the same. And then this hypotenuse, we just multiply by the square root of 2. So it's just 10 root 2. So that one's pretty straightforward. Now, let's say this time we're given the hypotenuse is 8. Okay, the hypotenuse is equal to x root 2. That means to find the leg, I have to divide by the square root of 2. So let's talk about how to simplify that. 8 divided by the square root of 2. You rationalize it by multiplying by radical 2 over radical 2. And that's going to give me 8 radical 2 all over 2. Because radical 2 times radical 2 is 2. That's how we clear the radical. And that gives us 4 root 2. Well, we know that both legs are the same. So that means this other leg must also be a 4 square root of 2. And that's how you handle those special right triangles. And again, you need to know those really well. Now let's look at SOHCAHTOA. Okay, SOHCAHTOA is sine, cosine, and tangent. And sine is equal to your opposite over your hypotenuse. Cosine is equal to the adjacent over the hypotenuse. And tangent is equal to the opposite over adjacent. So let's look at each scenario. So let's say we're given this angle over here is 32 degrees. Okay, and we don't know this opposite side, but we do know the hypotenuse is 10. Okay, this one is, well, from that corner, this is my opposite side. And of course, I've got the hypotenuse, so this one is a sine problem. So the sine of 32 degrees would be equal to the opposite, which is x, over the hypotenuse, which is 10. Then you're going to grab your calculator. You're going to change the sine of 32 to a decimal, and you're going to multiply it times 10, because I'm just going to basically treat this as a proportion. So x is equal to sine of 32, and then get that full answer times 10. So make sure you find the sine before you multiply by 10. And that's how you'd set that first one up. I'm not going to do it. You can grab a calculator and calculate that. So that's how a sine would work. Okay, let's look at tangent. Okay, tangent involves your opposite and adjacent. So let's say we're given this angle over here as 20 degrees. Okay, and the side over here is 4, and we need to know this other leg. Well, this one's a tangent because I've got my opposite and I've got my adjacent, and I don't have my hypotenuse at all. Whoops, that's supposed to be an x, meaning not, and instead of x as a variable. But we don't have the hypotenuse. So you're going to set this up as tangent of the angle. In this case, the angle of reference is 20 degrees, and it's equal to my opposite, which is x, over my adjacent, which is 4. And again, you're going to grab your calculator, you're going to type in the tangent of 20, and you're going to multiply it by 4 because we're going to do a cross product. And x is equal to tangent of 20. Find that answer by hitting enter, and then take that answer times 4. So grab your calculator and do that one. Okay, and then the scenario for our last trig function. This one I'm going to do a little bit differently. Okay, let's say that we know the adjacent is 5, and we don't know the hypotenuse. We're going to call it x, and we're given this angle over here as 28 degrees. Okay, so from this angle, this reference angle, 5 is my adjacent side, because remember, opposite's always on the opposite side of the triangle, and you get your hypotenuse. So it is indeed cosine. So the cosine of 28 degrees is equal to my adjacent, which is 5, over my opposite, which is, or my hypotenuse, which is x. Now the reason this one's different is when I go to set up a proportion, I'm going to end up having x times cosine of 28. So this time I'm not multiplying. I'm going to have to do a little bit of dividing here. And then of course when you do a cross product, you get 5 times 1, which is 5. Now to solve for x, I've got to divide by the cosine of 28. So you're going to take in your calculator 5 divided by cosine of 28, and that is what the length of x is going to be, which is, of course, the hypotenuse. And those are your 3 trig functions. Now, I did want to show you one other possibility with one of the trig functions, and that's what if you don't have an angle? So let's say we're missing this acute angle over here, but we know that this side is 4 and this side is 6. We had a triangle like this a few minutes ago. What's this angle measure? We don't know, but you can still use a trig function to figure it out. So you decide, which 2 sides do I have? Well, I have my 2 legs. The only one that doesn't deal with the hypotenuse is tangent. So this must be a tangent. So this is tangent of our unknown angle, and I'm going to call that angle theta. And it's equal to the opposite over the adjacent. So I'm going to put this as 6 opposite over adjacent, which is 4. And I need to solve for theta. Now to find an angle, we've got to use inverse. So on your calculator, you're going to use your second function button and get the inverse of tangent, and then take the ratio 6/4, or you can even type in 3/2 because that's 6/4 reduced, and that will give you the angle theta. And there you go, and that's how you find angles using your trig functions. Okay, now let's talk about areas. Okay, so areas of polygons. Most of these are pretty easy, so we can just review them. Okay, so the area of a rectangle, you just need to know your length and width, and then multiply length times width, and that's equal to your rectangle. Okay, triangle, you've got to figure out this height here. So let's say that's h. It's just 1/2 the base, and the base becomes whatever side your height is drawn to. So that's your base. 1/2 of the base times the height. Okay, isosceles. Isosceles is a little bit different because we know these two sides are the same. You're going to drop your altitude down, and it splits this opposite side, this little side, the base, into 2 equal parts. So you can always use the Pythagorean Theorem to find a missing side if you need to, or one of your trig functions if you have an angle down here to find it. But again, you're just going to use 1/2. In this case, the base is down here, and we drew in height. So 1/2 base times height. Equilateral triangle. There's actually a shortcut for this one. So we know on an equilateral, all 3 sides are equal. So I'm just going to call each side S. Okay, so there's a quick way, and it's just S squared times the square root of 3 all over 4. And that's a little shortcut for the area of an equilateral triangle. Okay, for a square, squares are easy. It's just side and side. So side times side is just side squared. Now sometimes you have to use the fact that you have a 45, 45, 90. If you're, let's say you're given your diagonal, you're going to have to use your 45, 45, 90 rules to work backwards to the side to then find the area. Okay, parallelogram. Parallelogram, let's say you've got a side of, let's say 4 and 6 again. Okay, you can't just multiply those because that's not your height. So what you have to do is you have to go in somehow, usually using trig or a special right triangle, find your height, and then you take the height times the base. So it's like a rectangle, and in this case it would be the height times 6, and 6 is your base because that's where the height is drawn down to, is to the base. Okay, pentagon and hexagon. We're going to assume that these are regular polygons, meaning all the angles are equal at the vertices and all the sides are equal. So if that's the case, then we can use 1/2 AP, where A is your apothem and P is your perimeter. So to remember what an apothem is, that is from the center directly to the side. The perpendicular distance, the shortest distance from the center to the side. So 1/2 AP, A, which is your apothem. Whoops, apothem. And then P is your perimeter of the entire polygon. So P is perimeter. And we're going to be working through a few of those in the prerequisite packet. But you may have to use a little trig to figure out that apothem to find the area. So those are your area formulas you need. Now let's talk about properties of quadrilaterals. This is the last concept you need to know from geometry. Basic, I mean, you need to know geometry, but some review topics. Okay, properties of squares. So let's talk about that. Let's draw in diagonals first. So we've got our diagonals, and we know our diagonals are the same length. Okay, we can also start marking sides. So let me use some colors here. We know on a square, all 4 sides are equal. We also know that the diagonals are perpendicular. They cross at right angles. So all 4 of these angles are right angles. And then also on a square, don't we know that the angles at the vertices are also right angles? So we've got actually 8 right angles inside of a square, which help us a lot because we can use the Pythagorean theorem, or knowing that this diagonal is bisected and this diagonal is bisected and the diagonals are the same length, you actually have 45, 45, 90s within a square. So those are the properties of the square. And then if you wanted to go back and say, okay, this is 45 degrees, which means this is also 45, and this is also 45, and that's also 45, and that's 45, and that's 45, and that's 45, and that's 45. So they're all 45 degrees. Okay, now let's talk rectangles. Again, let's draw in the diagonals. There's a diagonal, diagonal. Now, rectangles we know have our 4 right angles. So let's go ahead and draw the right angles in. We have right angle here at each of the vertices. Now, the diagonals at the center are not right angles, but we do know that the angle here is a vertical angle to the angle on the bottom. So the top and the bottom are both the same, and the one on the left and the right are the same because they're also vertical angles. Okay. We also have, since the diagonals, the full diagonals are congruent, and they're also bisected. So those 2 segments are the same, as well as those 2 segments are the same. Now what you've created are isosceles triangles, and I'm going to just outline one of the isosceles triangles. That's an isosceles triangle, so we know that these 2 angles are the same because they're base angles, and these 2 angles are the same as those red ones up top. And then let's pick another color. We haven't used black yet. That means these angles are also the same because we have an isosceles triangle on the left side. I'll darken it in black, and it also matches the one on the right. And we have 2 pairs of isosceles triangles. So that should help. And of course, these are parallelograms. So the top is parallel, the sides are parallel. You can talk about alternate interior angles. Same with the square. The top is parallel to the bottom, and the sides are parallel to each other. Because, again, squares and rectangles are types of parallelograms. And let's stop with the last and final. Let's talk about a parallelogram. Okay, parallelogram properties. Well, just by definition, we know that a parallelogram has parallel sides. So this side, I'm just going to indicate with some arrows, is parallel to this side, and this side is parallel to this side. There we go, just with some arrows to indicate that. We also know we have some congruent angles. The opposite angles are congruent. So this angle over here is congruent to this angle over here. That's the full angle at the vertex. The same with these 2. This angle, bottom left, is congruent to the top right. Now, hopefully you remember, since this is a parallelogram, the angles here, these 2 adjacent angles, are also supplementary. So I'm just going to type supplementary, meaning they add up to 180. And then let me grab my pen again. We also have vertical angles at the center. So this green angle is congruent to this green angle, and this green angle is congruent to this green angle. So those are congruent. We also know sides. This side is congruent to this side, and this side is congruent to this side. So the opposite sides are congruent, opposite sides are parallel, opposite angles are congruent. And then, of course, we've got some congruent triangles because we have alternate interior stuff going on. So we have this angle right here is congruent to this angle here by alternate interior because we've got parallel sides on the left and the right. Same with the top and the bottom. So we have this angle is congruent to this angle, and of course the other pairs are too. So let's mark those. This angle up here is congruent to this angle over here, and likewise this one up here is congruent to this one down here. I'll mark those slightly differently. There you go, and you've got all these congruent angles and congruent sides and supplementary angles. So lots of properties with quadrilaterals. And really, if you have those foundational skills, those are the main concepts you're going to need in geometry for pre-calculus. And again, I would focus on making sure you know your special right triangle rules because those build the unit circle. So there you go. There are the properties and actually concepts, topics you need to know from geometry to be successful in pre-calculus. I hope this video was helpful.